Kia ora and welcome to video 7 in the series Delightful Differentiation. This video is going to be presented by a former student of mine, Karen. Karen is currently studying mechatronics engineering alongside German at university. She was a brilliant student in my class, always very, very hardworking, asking lots of questions to make sure she understood things and completing all the questions in the workbook and some. The problem that she is presenting today is actually quite a neat question, very short if you notice the trick to solving the problem. We're finding a simplified expression for the derivative of this function. So like I said, there is a bit of a trick. It only takes Karen a few minutes to go through it. Thank you, Karen, for presenting, and we'll catch you in the next video when you're back with me.
Hi guys, I'm Karen. I was in Mr. Wallen's Schol class 2 years ago. I'm currently studying mechatronics engineering and German at the University of Auckland. So today we'll take a look at this question together to find the simplified expression for dy over dx for the function shown on the right hand side. So by looking at this question, the first thing that comes to my mind is that it's sort of in this infinite loop, right? So it just goes on and on forever on the right hand side. So let's take a look at step 1 of the question. If we observe what's on the right hand side of this red line over here, we can see it's essentially just y by itself, right? So we can represent this term using y in here. So by rewriting the equation, we'll have y equals square root x plus ay. And moving on to step 2, what we need to do is to get rid of this square root sign on the right hand side. So by squaring both sides at the same time, then we will end up having y squared on the left hand side and x plus ay on the right hand side. So what we need to do is move that ay term to the left hand side so it's nice and clean. So moving on from that point, we'll be able to differentiate both sides and thus give us the final answer. So in step 3, one important thing to note is that remember our implicit differentiation. Every time we try to differentiate a term like y in this case, we need to multiply it by dy over dx. So y squared will become 2y times dy over dx, and y will just become dy over dx times a, this term over here. And if we differentiate the right hand side, then x will just be 1 in this case. So by taking dy over dx outside of the bracket and factorize 2y minus a, then we'll have dy over dx equals 1 over 2y minus a as our final answer. Thank you.